Student, now we are moving for the reaction of amine containing with benzene sulfonyl chloride, or in other words, with Hinsberge reagent. Now, first of all, what we take benzene sulfonyl chloride, we have to draw structure, or in other words, Hinsberge reagent, and reaction with amines. Now we are starting. First of all, ethane amine, that means CH3, CH2, NH2 is given, and this primary amine reacts with benzene sulfonyl chloride. Now the structure will be like this. So, ethane amine reacts with benzene sulfonyl chloride, then hydrogen and Cl will be removed, HCl will be removed, and these will be fused. That is why CH3, CH2 and this is, now it contains H also. So the name of this yield will be like this: N-ethyl, and ethyl group is attached on nitrogen atom, that means N-ethyl. This is benzene, this is sulfonamide because NH is also is there. N-ethyl benzene sulfonamide. This is the name of the yield. Now we can say that this is secondary sulfonamide. Here you can say this is sulfonamide. One alkyl group is there, one aryl group is there. That means for sulfonamide group, two alkyl or aryl group is there. That is why we can say that this is secondary sulfonamide. If in place of hydrogen, if ethyl will be there, then tertiary sulfonamide will be called. Okay, now we are moving further. Ethane amine, this is my primary amine, 1 degree amine. When ethane amine reacts with benzene sulfonyl chloride, then HCl will be removed. That is why N-ethyl benzene sulfonamide is obtained. So we can say that from 1 degree amine, primary amine, we can obtain secondary sulfonamide. Now we can say that when diethylamine is given, CH3, CH2 and CH2, CH3, and hydrogen will be there. So when secondary amine reacts with Hinsberge reagent, this is my Hinsberge reagent, or in other words, benzene sulfonyl chloride, benzene sulfonyl chloride, then what will form? Then hydrogen and chlorine will be removed, HCl will be removed, and these two reagents will be fused. That is why CH3, CH2 and CH2, CH3, and these sulfonyl group will be attached with nitrogen. So we can say that this is my N-ethyl, N-ethyl, N diethyl, N diethyl benzene sulfonyl chloride, N diethyl benzene sulfonyl chloride. Okay, here we can say that when primary amine and secondary amine, this is my diethylamine or N-ethyl ethanamine, N-ethyl ethanamine, this is my secondary amines. When primary amine and secondary amine, in other words, ethylamine and diethylamine reacts with Hinsberge reagent, in other words, benzene sulfonyl chloride, then N-ethyl benzene sulfonamide is obtained. Thereafter, N-diethyl benzene sulfonamide, N-diethyl benzene sulfonamide is obtained respectively. Here we are talking about specially yield. Now here sulfonyl group is there. Sulfonyl group, which is electron withdrawing group. Electron withdrawing group, and nitrogen containing hydrogen. So this substance like N-ethyl benzene sulfonamide became acidic, more acidic. Why? Because hydrogen is attached with nitrogen, and this sulfonyl group is electron withdrawing group. For being electron withdrawing group, this substance has hydrogen which is acidic. That is why this substance is soluble in alkali. This is soluble in alkali. Soluble in alkali. So we can say that why this substance is soluble in alkali? Because nitrogen containing hydrogen which is acidic. This hydrogen becomes acidic. That is why this substance is soluble in alkali. But now when this reaction is carried out, this substance will be formed. Like N-diethyl benzene sulfonamide will be obtained. But in this substance you can see very well that nitrogen does not having hydrogen. Nitrogen does not having hydrogen, so it is not an acidic. So this substance which is not acidic, that means which is insoluble in alkali. Insoluble in alkali. This substance becomes acidic. That is why this is soluble in alkali. And this substance do not have acidic hydrogen. That is why which is insoluble in alkali. So we can say that this reaction, in summary, ethylamine reacts with benzene sulfonyl chloride, in other words Hinsberge reagent, then N-ethyl benzene sulfonamide is obtained, and this substance contains hydrogen which is on nitrogen. So this becomes acidic. Now being acidic, it is soluble in alkali. But when diethylamine reacts with benzene sulfonyl chloride, then it forms as a yield N-diethyl. This is N-ethyl, this is N-ethyl, because ethyl is on nitrogen. N-diethyl benzene sulfonamide is obtained. This is my tertiary sulfonamide. But this substance does not contain hydrogen with nitrogen. That is why it is not an acidic. Here hydrogen is not presence with nitrogen. Here hydrogen is not presence with nitrogen. That is why it is not an acidic. So that is why we can say that it is insoluble in alkali. So secondary sulfonamide which is soluble in alkali, tertiary sulfonamide which is not soluble in alkali. But we can say that when we are taking the reaction of tertiary amine, when tertiary amine reacts with benzene sulfonamide, no yield will be produced. Why? Because nitrogen does not have any hydrogen. Nitrogen does not have any hydrogen. That is why tertiary amine does not react with benzene sulfonyl chloride. So we can say that here in this reaction, primary amine give this taste, secondary amine give this taste, but tertiary amine does not give this taste. In 1 degree and 2 degree amine, 1 degree amine produced secondary sulfonamide, secondary sulfonamide. 2 degree produced 3 degree sulfonamide. And tertiary amine does not give this reaction. So secondary sulfonamide which is soluble in alkali, tertiary amine does not soluble in alkali, and tertiary amine does not give this taste. That is why this reaction is used for separation of primary amine, secondary amine and tertiary amine. So we can say that the label will be like this. Write down the short note of separation for 1 degree amine, 2 degree amine and 3 degree amine. So whenever this type of question is being asked, then we have to write down this topic. So we can say that Hinsberge reagent or the reaction of amines with benzene sulfonyl chloride is nothing but the separation of primary, secondary and tertiary amine. So we can write over here separation of 1 degree amine, 2 degree amine and 3 degree amines. Nowadays benzene sulfonyl chloride, in place of this substance, para-toluene benzene sulfonyl chloride is also used. So here we can say that this is para-toluene sulfonyl chloride is also used. So para-toluene sulfonyl chloride is used in place of benzene sulfonyl chloride. Nowadays this reactant is used for separation of primary, secondary and tertiary amine. So we can say that the reaction of amine with benzene sulfonyl chloride, in other word Hinsberge reaction, and in other word separation of primary, secondary and tertiary amine, 3 short notes are having only one topic. Okay. Students, now we are moving for electrophilic substitution reaction of aniline. Here, first one will be your bromination, thereafter nitration, and thereafter sulfonation will be carried out. Here, we have to take bromination of aniline. Now, this is my aniline. Ring contain NH2. This is aniline, or in other word benzeneamine. Benzeneamine. When Br2 water, 3Br2, in other word bromination in presence of water. So when aniline reacts with water bromine water, you can say, hydrogen of ortho, para and ortho will be removed with bromine. So 3HBr will be removed, and now 3 bromines, 1, 2 and 3 will be going toward on 2, 4, 6 tripositions. So we can obtain 2, 4, 6 tribromoaniline. So when we say aniline reacts with Br2 water at room temperature, means at normal temperature this reaction will be carried out. This reaction will be carried out at room temperature in presence of water. That means we can say that aniline reacts with Br2 water at room temperature, at normal temperature, then 2,4,6 tribromoaniline, which are having white precipitates, white PPTs, obtain white PPTs of 2,4,6 tribromoaniline will be obtained. So IUPACine will be 2,4,6 tribromoaniline is obtained. But this NH2 group of aniline is more reactive. That is why 2,4,6 substituted derivatives is obtained. But mono substitute derivatives, for making mono substituted derivatives, what we have to do? We have to take here NH2, which is more reactive. First, what we have to do? First, this NH2 should be less reactive, and for getting less reactivity we have to take acylation. So here we will take this reaction in 3 steps. For making mono derivatives, for making mono derivative aniline, we have to take this reaction in 3 steps. Now which one is first step? First acylation would be there. When aniline reacts with acetic anhydride CH3CO twice O in presence of pyridine, when aniline reacts with acetic anhydride in presence of pyridine, which is strong base, then what will happen? Then the amino contained hydrogen, which is removed with acetate, that is why acetic acid will be removed, and this acyl group will be attached with the NH. So acetanilide NHCOCH3. In other words, you can write this structure in this manner, right? So acetanilide is obtained. What is the second name? What is the IUPACine of this compound? N-phenyl. This is phenyl group attached with nitrogen. N-phenyl ethanamide. This is my N-phenyl ethanamide, which is acetanilide. And After getting this compound, now bromination is carried out. Br2 in presence of solvent like acetic acid. So bromination will be occurred. That is why bromo will be going toward the para position of the acetanilide. So para-bromoacetanilide is obtained. What is the name of this compound? Para-bromo or 4-bromoacetanilide. Para-bromoacetanilide is obtained. After getting this compound, when hydrolysis is carried out, then what will happen? Then this NHCO bond will be broken. Hydrogen is going this side and OH will be going on this side. So OH and H will be added. That is why this is NH2, this is acetic acid. So this is para-bromoaniline or 4-bromoaniline. Para-bromoaniline or 4-bromoaniline is obtained, and this will be your acetic acid. So we can say that when aniline reacts with, first one, aniline reacts with bromine water, then only one product, but at 3 stage, 2, 4, 6, tri-bromo derivatives of aniline is obtained. So aniline reacts with Br2 water at room temperature, then 2, 4, 6 tri-bromo aniline is obtained. But when aniline first get acetylation, thereafter acetanilide is obtained. After bromination, para-bromoacetanilide is obtained, and after hydrolysis, para-bromoaniline is obtained. So we can say that second reaction is for making mono derivatives of aniline. Second reaction is for mono derivatives, and first reaction is having tri-bromo derivative of aniline. So here what we have done, in this first reaction, NH2 are very reactive group. NH2 is very reactive, but in this reaction, when acylation is taking place, this acetanilide, this anilide group, which is less reactive, this acetanilide, this anilide group is less reactive than that of amine. That is why second reaction is having only mono derivative aniline. So we can say that when aniline reacts with acetic anhydride in presence of pyridine, then acetanilide is formed, and thereafter bromination in presence of acetic acid, then para-bromoacetanilide is obtained, and after hydrolysis we can obtain 4-bromoaniline or para-bromoaniline. When para is used, this is common name, and when 4 number is given, this is IUPAC name, 4-bromoaniline or 4-bromo-benzeneamine. So this was my electrophilic substitution reaction. Now first one is completed, which is bromination. Now we are moving for nitration and thereafter sulfonation. Okay. Students, now we are moving for electrophilic substitution reaction of aniline. We have discussed about bromination. Now we are moving on nitration. First one, we have to take in this nitration, first one, aniline is to be taken. When aniline reacts with the mixture of concentrated HNO3, concentrate H2SO4 at 288 Kelvin temperature, then ortho, because this NH2 is ortho para-directing group, that is why two products, O-nitroaniline and P-nitroaniline is obtained. O-nitroaniline and P-nitroaniline is obtained, but besides these two products, if you obtain only meta-directing product, that means meta-nitroaniline. So we can say that when aniline reacts with the mixture of concentrate HNO3 and H2SO4 at 288 Kelvin temperature, then O-nitroaniline, ortho nitroaniline, thereafter para nitroaniline, and besides these two, meta-nitroaniline is obtained. O-nitroaniline, para-nitroaniline and meta-nitroaniline is obtained. Here this product will be minor product because it is obtained by 2%, it is obtained by 47%, and it is obtained by 51%. Here we can say that aniline reacts with the mixture of concentrate HNO3 and H2SO4 by 288 Kelvin temperature, then O-nitroaniline, which is in minor, and P-nitroaniline, which is in major substance, are obtained. But here, why meta-nitroaniline is obtained? This is the question mark. Why meta-nitroaniline is obtained? Why? Here, amino group is ortho para-directing group. That is why product will be formed on ortho para. But there should not be produced meta derivatives. So we can say that here only ortho para positions containing nitro will be obtained, but meta is also there. Why? Here hydrogen of this nitric acid and H2SO4, which is on nitrogen. That is why aniline is converted into anilinium ion. So this hydrogen is going toward the nitrogen. That is why anilinium ion is obtained. This is what anilinium ion is obtained, and this anilinium ion, which is meta-directing group, this is Na3 plus anilinium ion, which is meta-directing. That is why meta-nitroaniline is also obtained. Okay. So here three product, ortho, meta and para, by 2%, by 47% and by 51%. This is minor product, this is major product is obtained. Okay, now if we want to take only para-nitroaniline, if we want to take only para position nitro, so we can obtain these reaction in three ways, by three steps. First one is acylation. when aniline get acylated, here acetic anhydride is given in presence of pyridine. When aniline reacts with acetic anhydride in presence of pyridine, then what will form? Then this hydrogen is removed by acetate ion, that is why CH3COOH is obtained, and this acyl group will be obtained toward the nitrogen. So acetanilide, you can say that NHCOCH3 acetanilide is obtained. When aniline reacts with acetic anhydride in presence of pyridine, then acetanilide is obtained. After getting this substance, obtaining this substance, we have to take a nitration by using concentrate HNO3 and concentrate H2SO4 at 288 Kelvin temperature. Then what will form? Then this group is ortho-para-directing, but para is the major product. That is why para-nitroacetanilide is obtained. That is why para-nitro this is para-nitro acetanilide is obtained, and by hydrolysis, we can obtain H and OH. So OH will be going on this side, that is why acetic acid will be removed. So CH3COOH will be removed and hydrogen will be going toward nitrogen, that is why aniline is formed, and on para position nitrogen is as it is. So this is my para-nitroaniline. Para-nitroaniline. So here NH2 was more reactive, but by acylation it is converted into anilide group, and this is less reactive than that of amine. Here NH2 is more reactive, that is why by acylation we have to produce anilide group, and this anilide group is less reactive than that of amine. That is why only one product, para-nitroaniline is obtained. So we can say that here when aniline reacts with the mixture of concentrate HNO3 and H2SO4 by 288 Kelvin temperature, then ortho, meta and para-nitroaniline is obtained. But when aniline reacts with the mixture of acetic anhydride and pyridine, then first form acetanilide, thereafter by nitration at 288 Kelvin, then para-nitroacetanilide is obtained, and by hydrolysis we can obtain para-nitroaniline. So here only one product is there. Why? Because anilide group is less reactive than that of NH2. That is why only one product is obtained. So this was my nitration of aniline, and which is electrophilic substitution reaction. Okay. Students, now we are going for sulfonation of aniline. Here we are taking the reaction of electrophilic substitution reaction of aniline. First one was bromination, second one was nitration, third one which is sulfonation. Here first of all we have to take aniline reacts with concentrated H2SO4, then this sulfuric acid which is added toward this NH2 group, right? So anilinium, you can say anilinium hydrogen sulfate is formed. What is the name of this compound? Anilinium. This is anilinium hydrogen sulfate. I will write anilinium hydrogen sulfate is obtained. After obtaining this substance, when 453 to 473 Kelvin temperature is being given and then heated, then what will happen? Then this SO3H, in this compound, SO3H group will be going toward the para position. From this compound, SO3H group, sulfonic SO3H group will be moving toward the para position. That is why here you can say SO3H will be moving. From this compound, SO3H group will be moving toward the para position. So this compound is obtained, which is sulfanilic acid. Here you can say that sulfanilic, this is market name or common name. But this is your benzene sulfonic acid and this is amino group, para amino benzene sulfonic acid. Para amino benzene sulfonic acid, para-amino benzene sulfonic acid is obtained, and after this sulfanilic acid, it will be converted as Zwitter ion, because this is amino, this is sulfonic. Now hydrogen of this group, hydrogen of this sulfanilic will be moving toward the NH2, because nitrogen, which is Lewis base, that is why it will accept the hydrogen, so it will convert it into anilinium ion, right? This is anilinium ion, so Na3 plus, and here H is moving from here, so SO3 minus will be obtained in this compound. In this compound, acidic group and basic group. Here acidic group and basic, both group are present. That is why this substance is amphoteric in nature, and it is doing both the cations and anion, both the work. That is why it is Zwitter ion. So this compound will be known as Zwitter ion. So we can say that when aniline reacts with the concentrate H2SO4, aniline reacts with the concentrate H2SO4 sulfuric acid, then anilinium hydrogen sulfate is obtained, and by heating with 453 to 473 Kelvin temperature, it is converted into sulfanilic acid, because sulfonic group will be going toward the para position. So sulfanilic acid is obtained, which is having an IUPAC name will be para amino benzene sulfonic acid, and it will accept the H plus from sulfonic group. That is why it will convert into Zwitter ion. So we can say that this is the reaction, this is the preparation for sulfanilic acid or Zwitter ion. So in other words, we can say that in exam, it is a best conversion for preparation of sulfanilic acid from nitrobenzene. Nitrobenzene is converted into aniline, and thereafter aniline is converted into anilinium hydrogen sulfate, and which is converted into sulfanilic acid. So it is a conversion of nitrobenzene to sulfanilic acid. Okay.